In this video, I'll talk about the difference between C++ types and the Java types. So let's start. Let's start from some simple example. So let's create some class and then the function which will work with this class, with the objects of this class. Okay, so let's see. So we need to create, for example, we can create the class card and then create the function which will transfer the money from one card to another. So we need to create class. In Java we need to just create it as static, because so to just make it independent from the main, or we can just do it in a separate like file. Yes, so it will be the same. So I will just create it as a static. So static class, for example, card, which can have the methods like the files like think car card name string. Okay, the expiration date, expire date, or expire month. Maybe we can just do it. It can be date time or it can be string. It's not the case. And string maybe bank name, and then maybe like int, for example, amount. Yes. Okay, then we can just create function which will be also static, because we need to make this function as the main function, like independent from the object of the main class. So static transfer, maybe it will be boolean, so it will be boolean, so it will just return the status of this transfer operation. So if it like fails, then it will just return false. Or we can just do it simply with some examples, some which crashes, which just throws some exceptions. But simply let's do it like card from some, simply like let's do it like the boolean. Okay, card 2, and then int amount. Okay, and then we will check if amount is enough. Yes, of course, like experienced programmers can say that you need to create getters and setters, but it's out of scope of our like tutorial, and this video is for the beginners. Okay, in most cases, the Java developers uses the getters and setter functions to get access to this like this kind of files, okay, and make files as private. But for the beginners, it will be like the same. So it will be like correct. If amount card from amount is less than amount, then we will return false. Else we will just take amount, decrease the amount of the card from, and increase the amount of the card to. Return true. So anything is okay for our case. Yes, so let's check. So any beginners will do it like this, and they will be absolutely correct. So let's check it, let's demonstrate it. So we have two cards, card 1 and then not there, okay, we need second card, and then I can show it the same way. So, and then let's check if transfer function works. Correctly. So let's println the and we will just make sure that everything is okay here. Okay, it has like transferred and everything is okay. But when we do the same thing in C++, what happens? So let's copy it like this classes like this and like this to the C++. So Java is C-like language, and so everything. So most of this we will not. So we don't need to this static because like we don't have any class. So in C++, so here we can use class or like the struct, it will be the same. So if it's class or it is struct, here if I don't mistake, okay. Also we don't need the static method because if I don't mistake, it will be because also what string, why it works like this? Because also here we don't need any class, so we don't cover it with any classes, so it's not contains in any classes, so it will be like independently in any case. So we don't need the word like static. So make it static. Why it has like this? Copy it like this. So okay, and it's the same thing, but so newbie programmers will be sure that it will work, but it doesn't work. So let's see it. Let's copy this one. So we don't need it. And also we don't need to create it, so it will not work in C++. So in most cases it's same. So we have just, and so we have said about this one. We have the same function, and then let's try. So junior programmer can just be sure that this works like samely. But it doesn't. So after the class definition. Okay. Yes. Okay. It's a cut from mode. Why? It's by default it's like the private is. So let's do it like structure. Well, we can just do it like structure and then it will be the private, or we can just add here the public keyword, which will be So it will not work. Why? So here some junior programmers can say that you need to just use this one, the references, the referencing, and it can correct it like this. Yes, it's also correct, and then but it doesn't like explain why it will work like differently. But here, so junior programmer can just think that this is Java and this is C++, and then the functions of Java and the functions of C++ works differently. But it's not fully like correct. Okay, so I will just say about it in the end of this video, and then let's see the next example, next difference, next like example. So let's make the bank like the another class, banks as another class. So for example, here we can just create static class bank, and it has a name and maybe address. Okay, here also we don't need the bank name, we need the bank. And also try to just create one bank for both of them. That's nice. And then here it will be not correct. And let's do the same thing. So let's change the name of the bank. For example, we have changed this bank to the Jusam bank, and let's just print out the bank name. And it will be changed, so any like junior programmer will do like this, and they will be correct. The code will be correct. But let's see it in C++. Okay, we can just create it as a structure, as I said before. So because structure and classes are like the same, but classes has more like expanding, more like opportunities and more like the details. So structure is a simple case of the class in C++. Okay. So also let's do like this, and let's clear this one and this one. Let's do the same thing as Java. We will create new bank and we will just print out. We will just change bank name and then print out the name of the bank second time. Okay, and let's see. Okay, here it says string. Okay, in C++, the built-in string type is from the lowercase letters. Okay, it's expected, and then C++ like requires a semicolon after the I have not changed it after the class declaration. Why it have not? Because I have not changed it here. Okay. Okay. So let's see. So it have not changed in this case. Okay, what happens? So the hint is like the two cases are the same. Error. It works like this. So if you know, Java types are like divided into reference types and the primitive types. But C++ types are all fully primitive. What does it mean? So when we work with Java types, when we work with program, so let's say that it's memory. Okay, let's create it more bigger. It's a memory area RAM is, and here there is it contains some like call stack for each function, and when we just call when we just start program for the main function, for the main function it will just create the activation record, and then when we call another functions, this for each function it will just create activation record in this call stack, and then takes control to this function. Okay, so when we create the card here in Java, yes, it will just create it like this. Okay, let's say firstly let's say about the C++, yes, because it will be easy to understand if we start from the C++. Okay, so in C++, simply when we create any variable here, or any variable here or here, it will just do like this. It will just, for example, here it will just create it. It will create it, for example, bank, and then it will create it with some variable. It will just reserve, when we create it, it will reserve the area in the memory in C++, and when we fill it like this, when we assign something, it will just fill this one. Here it will be like the name, and then here it will just create area for the string. Okay, and when we just create some card one, it will be created like this, and it will just create. When we assign it, it will create for each one like the different types. For example, card one, card holder name. Okay, let's see, card holder name like this. Here it will be filled like this. Okay, what? So Adam Smith and so on, and expiry months. Like this, and so on. When we create for the bank here for another type, so as the class is also is the type, the simple type in C++, it will be created like this, and then when we assign it, it will copy here all of them. Okay, let's make this the area like more bigger. This line code will this line of the code will not show to here. It will just copy it. Copy it here there. It will copy it there. So assignment will copy it there. And when we call transfer function, okay, let's just there. When we call transfer function, it will just create here the second activation record for the push activation record for the like transfer function, and then it will just make simultaneously make the copy of these cards. Wait, copy of these cards. So here card 1 will be not the same as this card. It will like be the copy of this card. It will fully copy of this card like this. And blank and so on. If you change here something, in this case, if you change here something, it will change these addresses, and then it will not like cause the. Okay, we have also the bank, the amount, and so on. Smith, and when we change, for example, amount or bank name or cardholder name, it will not be changed there. It will change there. It will be like this. So okay, bank will be like this. So if you change, when we change bank name, for example, there was in the function, if you change bank name here, then it will not be changed here. It will be changed in the new created banks. Yes, but when we make these types as a reference like this, then it will not create new one. It will simply like get the address of get access to this one, and then when we change it, it will be changed if you take it like this. Okay, but if you don't use it, it will change it will be this one, and it will not touch here. Okay, also in the second case, when we change the name of the bank here, it will change this one, but it will not touch this one. It will not touch for the card 2 and so on. Also here, if you change it in the method, it will touch here the only this one. Yes, but if you just okay, let's say like this, if you change here, the bank name will not be changed. This one will not be changed, it will be changed here. If you change the bank name like this here. Okay. So it's about the C++ types. But what happens in Java? What happens in Java? So in Java, also this code works the same. So they also have the call stack in Java, and there also will be like the exchange changed will be changed the variables and will be copied like this and so on. But in Java, but in Java, there is two kind of types. It's like reference types and the primitive types. So any class you created or built-in types, some built-in types have the reference types. So any classes also they are classes. When any reference types are classes, and then so here reference types will not directly save the like variables. They saves the addresses as the pointers. So in Trust Java types, if you just say it in like term of the in scope of the C++ terms, yes, Java types are the pointers in C++. They works Java like reference types are the same as C++ pointers. So Java doesn't like uh, we say that Java doesn't support the pointer, but in Trust Java doesn't support the directly like primitively access to the classes. They it supports only pointers. Okay, what happens here? Here, this bank will save some address, and when we just do new operator, when we do new operator, it will create this one. It will create this address, and then yes, for example, this one is, and then it will save here the address. And this address points to there. And when we just create the card1 here, it will just also do the same thing. Takes create the like the place to save the address as a pointer. And then when we just assign it to the new operator, will create some others will just how to say will reserve some address, and then the address of this pointer of this address, the address of these variables will just given here. And when we call some function, it also copies as C++ anything here, card1, card2, and then amount is. But here it will be copied the address, this one. It will be copied this one. And when you will just get access to the members, it will just change the members from this address. Okay, I have mistake. It's not small x1, it's 0x2. It will be changed like this. When we change the name of the bank here also any primitive type contains, so any reference types contains the address like this. Okay, let me just like this. And when we just change it, this one will be changed. So the same effect in C++ we can take from the pointers. So Java works. So for example, if you create like this is, and then if we create like this, and take access like this, so in C++ also we should just use, when we use the pointers, we should use the new keyword to get but here we will just take access from here. It's the same as if we dereference it, and so this line and this line is the same. So this code, so in Java, is like like corresponds to this kind of the code. So it's the same as the pointer. In Trust, Java like supports only the pointers, like this. Okay, here also we need it corresponds to this this kind of the code in C++. And let's see if we have not any mistakes. then we have anything like correct, like this. So it works like the same way. So in C++, when we do it like this, then this like the pointer is the same type as the class. It's like works the same way. So it will be copied here, but copying the pointer is easier than copying the like